So next topic is Ohm's law. You have read Ohm's law in class 10th. Any idea what you had done in class 8, 10th in the chapter electricity? And you might have done the experiment based on Ohm's law in your school. So Ohm's law relates potential difference, current, and resistance. Resistance is the constant here. So it basically relates potential difference and current. As I have said that if there is difference in potential, then charge can flow, and where there is flow of charge, there is current. है ना? तो अगर पोटेंशियल डिफरेंस होगा तभी चार्ज फ्लो कर सकता है, और जब चार्ज फ्लो करेगा तभी करंट होगा. So V and I, they are directly related. So which one is the independent variable and which one is the dependent variable out of I and V? रेजिस्टेंस तो कांस्टेंट है, वो तो बाद में आएगी. अभी वी आर टॉकिंग अबाउट V and I. Okay, now tell me one thing. See, if we place two containers at different height, okay, like this, then water flows from higher container to the lower container, right? So this flow of water is same as the flow of charge. In the same way, if we have two conductors and they are at different potentials, V1 and V2 is the potential of this conductor and V1 is greater than V2, then charge will flow from the conductor which is at higher potential to the conductor which is at lower potential till the potentials on both the conductors is the same. And because there is flow of charge and therefore there is current. What if I place one more container filled with water to a greater height? Then if we connect this through this tank, then water will flow at greater speed. है ना? तो यहाँ पे भी वाटर फ्लो हो रहा है, यहाँ पे भी वाटर फ्लो हो रहा है, बट यहाँ पर जो फ्लो है इसकी स्पीड क्या होगी? काइनेटिक एनर्जी ग्रेटर होगी, स्पीड ग्रेटर होगी, क्योंकि ऊपर से जितनी हाइट से आएगा, जितनी हाइट से आता है तो काइनेटिक एनर्जी ग्रेटर क्यों होती है? बिकॉज वी नो जो वाटर स्टोर्ड है उसमें पोटेंशियल एनर्जी एंड दैट इज इक्वल टू mgh. इफ यू इंक्रीज द हाइट, पोटेंशियल एनर्जी इंक्रीजेस, और जब वाटर फॉल करेगा जितनी ज्यादा पोटेंशियल एनर्जी होगी उतनी ज्यादा काइनेटिक एनर्जी में कन्वर्ट होगा, है ना? जिसकी हाइट कम है, इसका हाइट सपोज लेट से h डैश है, तो mgh dash is the potential energy for this particular tank. So its h dash is smaller as compared to h, है ना? तो it has less potential energy as compared to the tank above. So kinetic energy is less. Accordingly kinetic energy होगी, जो conversion होगा वो accordingly होगा, right? In the same way, अगर potential difference बहुत ज्यादा होगा, if one conductor is at very high potential and other conductor is at very low potential, then in that case, अगर very high very low तो charge जल्दी जल्दी flow होगा, तो current ज्यादा produce होगा. But if there is the difference in the potential of the two conductors is not very large, then yes. So we see current depends on potential difference. If we increase the potential difference, then current increases, and if we decrease the potential difference, then current decreases. So here current is the dependent variable. Current is the dependent variable and potential difference is the independent variable. Yes. One more thing. In some books, you will find, we can draw the graphs, and you have done the graphs in class 10th as well. So you will see two kinds of graphs for this. In some books, you will find I here and V here, while in some other books, I is here and V is. Usually how we take I and V? In some books, you will find V proportional to I as well. वैसे तो I proportional to V है, but किसी किसी बुक में आप देखोगे उसमें V is proportional to current है ना? Usually we take the variable which is independent on x-axis. Always we take independent variable along x-axis and dependent variable along y-axis. This is how we take. And because according to me, according to us, our theory, I is the dependent variable. I should be along y-axis because it is the dependent variable. And V should be along x-axis because it is the independent variable. Yes? है ना? हमारी थ्योरी के अकॉर्डिंग तो ये होना चाहिए. बट बुक्स में किसी किसी बुक में वी फाइंड कि V यहाँ लिखा होता है और I यहाँ होता है. और किसी किसी बुक में यहाँ के इसके अकॉर्डिंग V is proportional to I है. And from this graph I proportional to V है. तो हम किससे कंसिडर करें? हम V proportional to I कंसिडर करें या I proportional to V कंसिडर करें? डिफरेंस तो कुछ भी नहीं है देखा जाए तो. One is increasing, other is increasing. If we decrease the one, other will decrease. They are directly related. But it's about dependency of one variable on the other. So which variable should we take along y-axis and which should we take along z-axis? This x-axis. This is the question. जो independent है वो x में होना चाहिए और जो dependent है वो y में होना चाहिए, no doubt. But why do we see this thing in the book then? Is that wrong? Is this thing wrong? V proportional to I and V we take here and I we take here. Is this thing wrong? In both the cases, one more thing. In both the cases, we get this line, straight line graph. Experimentally, it is not straight. It is मतलब हल्का सा curvature आता है जब ऊपर जाके ऐसे करके, ठीक है? Theoretically, it is straight, but experimentally we get, at higher temp मतलब जब थोड़ा सा इसको increase करते हैं ना तो यहाँ पे after certain time you get curve like this. नीचे से straight and then you get this curve. Experimentally, but theoretically we get a straight line. For Ohm's law. देखो, ये वाला theory के according we should go like this. Because only where there is difference in potential, current changes accordingly. If you increase the potential difference, current will increase. If you decrease the potential difference, current will decrease. ठीक है, ये theory है. But experimentally, we can consider V proportional to I. Theoretically, it is correct. Experimentally, we can take this. Because when we perform Ohm's law in labs, we neither change voltage nor current. We change resistance we use a rheostat there, variable resistor, and we move the rheostat and change the resistor accordingly. We get the different values of V and I. Ohm's law. At constant temperature for a given dimension of the conductor, strength of electric current through the conductor is directly proportional to the potential difference applied across the conductor. So at constant temperature, we are saying कि किसी constant temperature पे electric current is directly proportional to the potential difference applied. Means current is the dependent variable and potential difference is the independent variable. Current is directly proportional to potential. So I is proportional to V. So if V is the potential difference and I is the current, then we write I proportional to V. And to remove the sign of proportionality, we always add a constant. And here the constant is 1 upon R. If we are writing I proportional to V, then we write I is equal to 1 by R into V, where R is the resistance of the conductor. The word resistance means something which resists, something which obstructs, because this is electrical resistance and we are dealing with charges which are moving. So there is something which is obstructing the flow of current, obstructing the flow of charges. There is something which is opposing the flow of charges, and that's resistance. So as in this case, you will find this at constant temperature in this law. These three words are very important at constant temperature. If you don't write, we consider these three words when we ask you to write Ohm's law in your exam. ठीक है, तो हम ये मान के चलते हैं कि that you will write this as well. ये ऐड करना बहुत जरूरी होता है at constant temperature. क्या मतलब है at constant temperature? Resistance depend करती है temperature पे. And what is the cause of resistance? How does resistance, it changes with temperature? How does it change with temperature? बताओ. Electrons, when we apply potential difference across the conductor, then electrons move in a specific direction. They drift towards the positive terminal, and there are some atoms or ions present in the conductor, and electrons collide with those atoms and ions, है ना, which are मतलब obstructing the flow of electrons. ना, those atoms and ions are actually, because they are colliding with the electrons and उनको allow नहीं कर रहे हैं, वो move नहीं करने दे रहे हैं, तो they are obstructing the flow of electrons. और क्या कर रहे हैं, वो resist कर रहे हैं, they are resisting the flow of electrons. Yes, and when we change the temperature, then collision is more frequent. Na? They collide more frequently. Resistance increases with rise in temperature for conductors. For conductors. Okay. So resistance is the ratio of potential difference across the ends of a conductor to the current passing through the conductor. And resistance is V upon I. We measure potential difference in volt and current is measured in ampere. Resistance ka unit, the unit of resistance is ohm. So ohm is volt per ampere. So we can define 1 ohm, right? It's easy now. No? You can define 1 ohm. If the potential difference is 1 volt and current is 1 ampere, then resistance is 1 ohm. And how do we find dimensions? Voltage is W by Q. Voltage is W by Q. Q is IT. And W is ML2T minus 2. Karo? Find karo dimensions. V is W upon Q. And I is the fundamental quantity. Yes. V is the derived quantity. So we need to express this derived quantity in terms of fundamental quantity first. W is force multiplied by displacement. So it is ML2T minus 2. So ML2T minus 2 upon IT, I square T ho jayega, and on solving, what will you get? ML2T minus 3, A minus 2. This is what you करवाऊं? हो गया? सेम आ रहा है? So how can we define 1 ohm? How do we define 1 ohm? It is the resistance of a conductor, or resistance of the conductor is said to be 1 ohm when potential difference is 1 volt and current is 1 ampere. The resistance of a conductor is said to be 1 ohm if 1 ampere current passes through a conductor having a potential difference of 1 volt. Okay. Now do this question. The potential difference between 2 points of a conductor wire carrying current of 2 ampere is 0.1 volts. Calculate the resistance between the 2 points. Do this question now. First write what is given to us. Current is given. Voltage is given. To find R. R is equal to V upon I. Now we will put the values 0.1 upon 2. What are you getting? 0.05 is the correct answer. Easy now? Next question. The potential difference between the terminals of an electric heater is 60 volts. When it draws a current of 4 ampere from the source, what current will the heater draw if the potential difference is increased to 120 volts? So, we have an electric heater. The potential difference between the terminals of an electric heater is 60 volts when it draws a current of 4 ampere. What current will the heater draw if the potential difference is increased to 120 volts? If we increase the potential difference, then current will also increase. Because we have an electric heater, so we'll keep the resistance same for the electric heater. So first find R, or we can do one more thing, no? Because V is proportional to I. So we can simply write, V2 by V1 is equal to I2 by I1, because we are keeping the resistance same. I2 is equal to V2 by V1 into I1. This is how you have done. Madhav, ऐसे किया है? (120 by 60 into 4). वैसे भी एक चीज है कि अगर आप ट्वाइस कर रहे हो इसको वोल्टेज को, वोल्टेज को अगर आप 2 times इंक्रीज करोगे, then current will also increase by factor of 2, है ना? ऐसे भी कर सकते हो. Second, you can find resistance from here. It's V1 by I1. You can find resistance first. It is 60 by 4. What will you get? 15 ohm. And then you put the value of resistance here. You'll get I2 as V2 by R. Yes. So V2 is 120 upon 15. You can do like this also. है ना? तो आप ऐसे भी कर सकते हो, ऐसे भी कर सकते हो. फर्स्ट, सेकंड और थर्ड क्या है कि अगर ये ट्वाइस करेंगे तो ये भी ट्वाइस हो जाएगा, तो ये थर्ड हो गया. So there are 3 ways. In different ways you can solve this problem. Ohm's law is not a universal law. See, we had done one universal law in our lower classes. Universal law of gravitation. It is applicable everywhere. है ना? Universal laws are those which are applicable everywhere, but Ohm's law is not universal law, we cannot apply Ohm's law everywhere under all conditions. It is obeyed by metallic conductors, which accordingly are called ohmic conductors. We call metallic conductors ohmic conductors because they follow Ohm's law. At very high currents or voltages, even ohmic conductors do not follow this law. I told you na ki we get the straight line, but when we increase the voltage or current, then it becomes, a little curved. After some time, na, we get line like this. पहले straight आएगी, फिर हल्की सी curve हो जाती है experimentally, but theoretically we draw the line straight. ठीक है? तो Ohm's law सिर्फ conductors में applicable होता है. That's why the conductors are called ohmic conductors. And substances which do not follow Ohm's law, insulators, semiconductors, जो Ohm's law को follow नहीं करते हैं, उन्हें हम बोलते हैं non-ohmic. Second, even at high currents and voltages, when we increase the current or increase the voltage, even ohmic conductors which are following Ohm's law, they even do not follow Ohm's law. Okay? Symbol of resistance is zigzag line. We draw a line like this. This is the symbol of resistance. And if we have variable resistor, then how do we draw it? एक arrow बीच में आ जाता है. So symbol of variable resistance is this. Yes, and variable resistance is also called rheostat, and there is another way of drawing variable resistor. What is it? So there are 2 ways of drawing variable resistor. Second way of drawing variable resistor is we draw a resistor and then we mark arrow like this. Either we can use this or we can use this. Okay, so there are 2 ways of drawing variable resistor to this now. See, we have a conductor and these blue dots represent electrons. So when we apply potential difference across the conductor, then electrons will drift towards the positive end. And there are atoms or ions present in the conductor. And because of the collision of electrons between the atoms or ion, there is resistance. They offer resistance. They collide and this is the cause of resistance. Okay. So conductance is, see, resistance and conductance, right? Resistance means something which is obstructing or opposing or resisting the electrons, है ना, जिससे इलेक्ट्रॉन्स मूव ना करें. एंड कंडक्टेंस ऑन द अदर हैंड, जिससे कंडक्ट हो, जो मूव करने में हेल्प करे या कंडक्ट करे, राइट, दैट्स कंडक्टेंस. तो कंडक्टेंस इज द रेसिप्रोकल ऑफ रेजिस्टेंस, है ना. Reciprocal of resistance is called conductance, and conductance is 1 upon resistance. It is denoted by letter G. Capital G is 1 upon R. Resistance is measured in ohm, OHM. On the other hand, conductance is measured in mho, MHO. ठीक है, yeah, or you can write per ohm or Simon. Any unit you can write for conductance. And dimensional formula, you can find out whatever formula that you have written for resistance, na, take the reciprocal and you'll get the dimensional formula of conductance. It's easy. Yes. Ohmic conductors are the substances which obey Ohm's law. This we have discussed. Are called ohmic conductors. Examples are metals. For linear or ohmic conductors, I versus V graphs are straight lines passing through the origin as shown below. If we have ohmic conductor, we get a straight line, and this straight line passes through the origin. If we have potential difference 0, then no current will flow. V 0, then I is 0. Okay. And if we find slope of this VI graph, then what will we get? 1 I upon V, and I upon V is 1 upon R, because R is V upon I. R is V upon I. So if we have I upon V, then we'll get 1 upon R. 1 upon R is conductance. Okay. Similarly, as you have this IV graph, in the same way you can have VI graph. And if we have VI graph and we find the slope, then by finding slope we get V upon I. V upon I is R. ठीक है? ये देखो. If we take any 2 points on this line, let's take these 2 points. Okay. So what is slope? How do we find slope? How do we find slope? If this point is, at this voltage V1, this is abscissa, na? Abscissa, x coordinate, yes. B is along x-axis, na? We will write V1 first, and then we will write I1. Coordinate of this point is this, and coordinate of this point is, accordingly we can take V2, I2. And how do we find slope? Y2 minus Y1 upon X2 minus X1. So Y2 is I2 minus I1 upon V2 minus V1. Because V is equal to IR, and I upon V is 1 by R. है ना? I इसको V को यहाँ लेके जाओगे तो R को वहां लेके जाओगे तो ये 1 upon R हो जाए. I upon V is 1 by R. So this is 1 by R you are getting here. Also we can find slope by taking, angle theta is given. So this is also equal to tan theta. You have read in class 11 in coordinate symmetry. Yes. In the same way, if we have VI graph like this, then again we'll take 2 points on the coordinate on this line, on the straight line. So coordinates of this point is, first we take the abscissa, it's I1 and V1, and here we have abscissa first and then we write ordinate. है ना? And when we take slope, it's Y2 minus Y1 upon X2 minus X1 again. It's V2 minus V1 upon I2 minus I1. Now V upon I is clear, because V is equal to IR, and therefore V upon I is R. So this is R, resistance. So here you'll get R and here you'll get 1 by R. So if you have IV graph and you are finding slope, then the slope is 1 by R. Again, you have to take the reciprocal to get the resistance. If you're asked to find resistance and you have IV graph और resistance बोल दिया निकालो, तो आपको slope से 1 upon R मिलेगा. R नहीं मिलेगा तो आपको reciprocal लेना पड़ता है. अगर आपके पास VI graph है and you are finding slope, तो आपको slope से you directly get the value of resistance. This is the difference. Here you will get the value of conductance and here you will get the value of resistance. यहाँ पे क्या करना पड़ेगा? बाद में एक स्टेप और हो जाएगा, एक एक्स्ट्रा स्टेप होगा आपका, जिसमें यू टेक द रेसिप्रोकल एंड गेट द वैल्यू ऑफ आर, एंड इसमें यू डायरेक्टली गेट द वैल्यू ऑफ आर. ठीक है. Write this, important. Okay, the current voltage graph of two metallic conductors is shown below. Which metallic conductor has the higher resistance? IV graphs are given. आपको बताना है किसका resistance high है. So when you have IV graph, what do you get? 1/R or R? From IV graph, when we find the slope of IV graph, we have I2 minus I1 upon V2 minus V1. Yes. So it's I upon V. I upon V is 1/R. And slope is also equal to tan theta. So this angle is smaller than this, है ना? This angle is greater. So let's take this angle as theta 1 and this is theta 2. So you can see that theta 2 is greater than theta 1. So it has greater slope. है ना? So less R, less value of 1/R, and it has greater value of 1/R. It has greater value of 1/R, therefore value of R is less here, greater R. So which graph shows greater resistance, higher resistance? Which graph? This one. This shows the higher resistance. Resistance of a wire. What is resistance? पता है हमें क्या होती है? What is the cause of resistance to collision? It occurs, है ना? It arises because of the collision of electrons with the ions or atoms of the conductor. And what are the factors which influence the resistance of wire? On what factors resistance of a wire depends? It depends upon the length. It depends upon the area of cross section. ठीक है? The resistance of the wire depends upon the nature of the material. It depends upon the temperature. See, there are four factors. Four factors: length, area of cross section, material, nature of the material, and temperature. Okay. So factors influence the resistance of a wire. The first factor that we have here is nature of the material. Specific resistance, rho or resistivity. Second, it is directly proportional to length of the wire. If we increase the length of the wire, then resistance will increase. And if we decrease the length, resistance will decrease. Third, it depends upon the area of cross section. It is inversely proportional to area of cross section. So for a thicker wire, we have value of resistance smaller or greater. If we increase A, then R will decrease. And if we decrease A for thin wire, R will increase. Yes. And it also depends upon temperature. See, resistance of conductor. मैं emphasize कर रही हूँ उस पे, conductors की बात हो रही है. So resistance of the conductor increases with rise in temperature. If we increase the temperature, the resistance of the conductor increases. Okay. So these are the four factors. So R is equal to rho L by A. Collectively, we can write like this. Okay. Because R is proportional to L, inversely proportional to A, 1 upon A. Na? So collectively, we can write like this. R is equal to rho L by A. We actually, when we write this, first we take R proportional to L, and then we write R proportional to 1 by A, and collectively we write R proportional to L by A, and then we write R is equal to rho L by A, where rho is the resistivity or specific resistance of the conductor. See, if we have, let's say, if we have two copper wires, you can see that we can change the length also. This is, L1 and this is L2. If you want to link, you can. A1, A2. So L2 is greater than L1, A2 is greater than A1. So they have different area of cross section and they have different lengths. So their resistance is also different. It has resistance R1, it has resistance R2. Now, because both the wires are made up of copper. This is copper wire and this is also copper wire. So they'll have the same resistivity value. So resistivity does not change with the length or area of cross section. Only resistance changes. So our resistance depends on 4 factors that we have discussed. It depends on length, area, temperature, and material. So out of these 4 factors, resistivity depends only on temperature and material of the conductor. Okay. Out of these 4, these two, temperature and material of the conductor. Resistivity depends only on these 2 factors. On the other hand, resistance depends on 4 factors. If we have 2 copper wire of different lengths and different area of cross section, then they have the same value of resistivity but different value of resistance. Okay, next topic. Resistivity of a material. R is equal to rho L by A. We know this relation now. So we can find rho. We can write rho in terms of R, L, and A. So rho is R A by L. You can see A is in the denominator now. So it will move to the other side and goes to the numerator and multiplied by A, R. So R A by L we get. So we can find the unit of resistivity like this. Resistance is measured in ohm. Area in meter square. Length is in meter. By putting the units here, you'll get the unit of resistivity as ohm meter. Resistivity is a measure of resisting power of a specified material to the flow of electric current. Okay, it is the measure of resisting power of a specified material. कोई particular material कितना ज़्यादा resist कर सकता है electric current को? कैसे resist करता है electric current को? That's resistivity. And resistivity of a conductor increases with rise in temperature. Okay, so it depends upon the material as well as on the temperature. It depends on 2 factors: material of the conductor and temperature of the conductor. Yes. Now we have questions based on this. At constant temperature for given dimension of the conductor, the strength of electric current through the conductor is proportional dash to the potential difference applied across the conductor. Yes, it is directly proportional. It is the correct answer. Next question. The symbol for variable resistance is? It's B. B. And C is inductor. Inductor. We'll study inductor in EMI or electromagnetic induction. Okay. The resistance of wire is R. The resistance of another wire of same material at same temperature is of twice length and diameter is. Solve this now. Now will you find the answer? We have a wire of resistance R. Its length is L, area of cross section is A. Now we have another wire of twice the length. So we have another wire of twice the length. Let's see. If we, increase the length and twice the diameter it is said, na? So its diameter is D and its diameter is, let's say, 2D. Then we have to find resistance of the new wire. Let's take this resistance as R dash. So because R is equal to rho L by A and A is pi R square, or we can write pi D square by 4. है ना? What is A? Area of cross section of the wire is area of the circle, na? It's pi R square and R is radius. Radius is diameter upon 2. So it is pi D square by 4. So for this we can write rho L upon pi D square 4. We can write like this. So resistance depends on L directly proportional to L and inversely proportional to square of the diameter. So here we'll write R dash, है ना? So R dash is equal to length is doubled and this pi D square by 4. D is 2D and 2D square by 4. So what will I write? What should I write? 4 L upon 2 to the 4 pi d square. Yes, एक तो ऐसे कर सकते हो. Second ये कर सकते हो कि you can write r dash proportional to, as we have this L upon d square here, na, in the same way we can write 2L upon 2d whole square. So r is proportional to 2L upon 4d square. बताओ क्या आएगा? So find r dash by r. R dash by r is L upon, this is 2 and this is 1, so 2L upon pi d square, and here we have रो भी तो आएगा साथ में, रो L by A होता है ना, and here we have 4 रो L upon pi d square. What will you get? 2 upon 4. R dash upon R is 1 by 2. And here also we are getting the same thing. 1 by 2. So R dash is equal to R by 2. Ohm's law is applicable to ohmic conductors only, non-ohmic conductors only, both ohmic, non-ohmic, vacuum tubes. For making standard resistance, wire of following material is used: nichrome, copper, silver, manganese. It's manganese. The best material for making resistance in resistance box is constantan, iron, silver, brass. It's constantan or manganese. A copper wire of cross-sectional area 2 millimeter square, resistivity is given, carries the current 1 ampere. The electric field in the copper wire is this, or this. You have to find electric field. Given क्या क्या है? Area of cross section given है, A is given, rho is given, I is given. You have to find electric field. Electric field is, see, we in Ohm's law we deal with V, I and R. वो तो समझ आता है ना? V, I and R होता है. And R is rho L by A, तो L और A का भी आना समझ में आता है. बट अब ये इलेक्ट्रिक फील्ड कहाँ से आ गया? इसका क्या करें? बताओ. Is there any relation between length and V and to get E? हाँ, ठीक है. Integral form था that we had discussed already. So E is equal to V upon X. Here we take it. Here we can take L. है ना? E is V upon L. V is equal to IR. R is rho L by A. है ना? कर रहे हो relate?
Yes, ma'am.
So these values are given to you. V is equal to IR होता है, ठीक है? And E is equal to V upon L, and R is equal to rho L by A. So we can write E as, because this V is EL na, from here. Is EL ko we'll put here. Okay, so we'll get EL is equal to IR, and R is rho L by A. Now we can cut this L, है ना? So E is equal to I rho by A. Now put the values here. I is 1 ampere, Rho is 1.7 into 10 raised to the power minus 8 and A is 2 millimeter square. Convert this into meter square. Yes. So 2 into 10 raised to the power minus 6. Now you will get the answer. It's 8.5 in 10 power minus 3 volt per meter. But it's third option, not 4. We have this power minus 3. We're getting 0.85. No? Dimensions of a metal block is given. We have to find the ratio of resistances between the square faces and rectangular faces. This is the metal block. So you can see that in this rectangle, we have in this cuboid, we have length unequal and breadth and height, they are same. No? They are equal. We have these two faces are square faces and these two faces are rectangular faces. ठीक है, तो हमने क्या फाइंड करना है, जो इसके स्क्वायर फेस है उसमें रेजिस्टेंस क्या होगा और जो इसके रेक्टेंगुलर फेस है उसमें रेजिस्टेंस क्या होगा. So we have these options. We have to find the ratio. कैसे निकालोगे? देखो, if you have to find this AB, na, resistance between these two ends, then you will take length of the wire as L, है ना? Length of this metal block as L. Here we have metallic block, na? So you'll take length of the metallic block as L. If you are considering your square faces, then this is the length. And area of cross section is B cross H. And if you are considering these two faces, then for length you have this B. This is B, na? Look at the arrow movement. This. And area of cross section is, this time area of cross section is L cross H. नहीं आया समझ. ठीक है, when you put the values, so you get the ratio as 2500 is to 1. आ जाएगा. Next question, this is important. This is the last question we are doing. Okay. So a negligibly small current is passed through a wire of length 15 meter and uniform cross-sectional area 6 into 10 raised to the power minus 7 meter square. Resistance is given, it is 5 ohm. Yes, it is 5 ohm. We have to find resistivity of the material at the temperature of the experiment. It's easy. You can do it. And how will you find resistivity? R is equal to rho L by A. This implies rho is equal to R A by L. Now put the values. It's 5, 6 into 10 to the power minus 7 upon length. Into 10 to the power minus 7 ohm meter. This is the resistivity. What is drift velocity?
I equals to A and
I is equal to A and EBD. Again, I have the same question. What is drift velocity? That's the relation between electric current and drift velocity. I have asked you, define drift velocity. What is it? हमने क्या डिस्कस किया था लास्ट क्लास में? In a conductor, we have free electrons. Yes. And these free electrons move randomly in different directions. Right? तो हम ये assume करके चलते हैं कि अगर ये वाला इलेक्ट्रॉन इधर जा रहा है तो we have one more electron which is just moving opposite to it. And if this electron is moving in this direction, then this electron is moving in this direction. So in this way, we just cancel these pair and net charge we assume is 0. So no net charge is flowing in the conductor. This is what we assume. Because अगर हम मान के चलते हैं कि अगर एक इलेक्ट्रॉन इधर है तो दूसरा इलेक्ट्रॉन उसके अपोजिट है. Right? This is one thing we are done. और उसके बाद हमने क्या करा था? When we apply potential difference, when we connect the conductor with the battery, Then these electrons, they move sensibly in an order and they move towards the positive plate. So motion of electron and motion direction of this electric field intensity, they are opposite. है ना? The direction in which electrons are flowing is opposite to the direction of electric field intensity. And what is the direction of current? It is same as the direction of electric field. So current flows in the same direction in which electric field intensity is pointing. Direction of electric field intensity and current is same, and electrons, motion of electrons is opposite, and this is the reason we write a negative sign in drift velocity. Negative sign indicates that VD and E, they are opposite to each other. They are moving in opposite directions. Okay, initially when they were moving randomly in different directions, we assume that they have thermal velocity, and that thermal velocity is of the order 10⁴ to 10⁵ meter per second. Yes. And after the electric field is set up, then electrons collide, frequent collisions of electron take place, and due to this, their velocity decreases to 10⁻³ to 10⁻⁴ meter per second. This is the drift velocity, and this is the thermal velocity that we had discussed. ये किया था. इसके बाद हमने क्या किया था? जो acceleration होगा, mass of electron, this force is equal to electrostatic force, है ना? तो minus EE, and from here we had written the relation of acceleration minus EE by m, and then VD is equal to average drift velocity. Average drift velocity is mean of all the velocities of different electrons which are moving in a conductor. Okay, is equal to average thermal velocity plus acceleration and tau. Tau is the relaxation time, and this is 0. This is the mean relaxation time. What is this tau? And how do we find mean relaxation time? Individual relaxation time को हम add करते हैं, and we divide it by number of electrons that we have, right? And what is relaxation time? It is a time elapsed between two successive collisions. U0 हो गया, तो VD क्या आएगा यहाँ से? A tau, and for A we can write this minus E tau by m. So this is the relation that we have got in the previous class. इसमें कोई doubt है? Please write this. Reduction of Ohm's law. ठीक है? For this, let's consider the same conductor that we consider. ठीक है? तो हम जो conductor लेते हैं उसको consider कर लेते हैं. We have a conductor. Draw this conductor first. Okay. Length of this conductor is L. And this is the electric field that we have applied here. Potential difference is set up. So how electric field intensity, potential difference, and length of the conductor, these three quantities are related? How these quantities are related? VE and L. देखो इसमें हमने electric field set up कर दिया, and electrons are drifting towards the positive terminal, positive end. This we had discussed, right? In drift velocity, electrons start drifting, they start colliding, the velocity decreases, right? And electric field is in this direction. The direction of electric field and direction of motion of electrons, they are opposing each other, right? So a potential difference is maintained, it is set up. So how these three quantities, electric field intensity, potential difference, and length of the conductor, they are related. If we assume that one electron starts moving from here and reaches here after some time, it starts moving from here and reaches this point. So it covers a distance which is equal to length of the conductor from one end to the other end. It covers the length of the conductor. So this is the length covered, distance covered by the electron. तो कैसे रिलेट करोगे? इलेक्ट्रिक फील्ड इंटेंसिटी क्या होता है? नेगेटिव ऑफ पोटेंशियल ग्रेडियंट. बताइए कहाँ पढ़ा था? सेकंड चैप्टर. ओके, So we can relate EV and L like as E is equal to V by L. E is equal to V by L. Any doubt in this? Is this clear? Okay, now what is drift velocity? How do we write drift velocity? It is minus E tau by M. Yes. And what is E? V by L. So V tau by M L. Any doubt in this? यहाँ तक कोई doubt है? Relation between electric current and drift velocity is? Electric current and drift velocity. What is the relation? I is equal to A N E V D. So for VD we can write this. For VD we can write this expression. Yes. है ना? तो VD के लिए हम ये expression लिख देते हैं. Neglect the negative sign and write this expression for VD. So what will we get? A and E. In the bracket we have E V tau by M L. So this is A N E square tau by M L in one bracket and V here. Define Ohm's law properly, completely. I is directly proportional to V. This we had discussed yesterday. And one more thing, at constant temperature. भूलना नहीं, constant temperature को तो बिल्कुल नहीं भूलना. करेगा. करेंगे. So, according to Ohm's law, current flowing through a conductor is directly proportional to potential difference applied across the ends of the conductor at constant temperature. If we change the temperature, resistance changes, motion changes, right? So I is directly proportional to V, and we can write I is equal to V upon R. So I is equal to V upon R, this we know. And from this expression that we have just found out, we can see that we have I is equal to A N E square, something like A N E square tau upon ML into V. So what value of R do we get from here? On comparing these two, you can write the expression for R as M L upon A N E square tau. ठीक है जी? मुश्किल है? कोई डाउट, कोई शक, कोई डिफिकल्टी? No? Great. So it's ml upon a n e square tau. Okay. So we can see that resistance of a conductor, it depends upon the length of the conductor. This is number one. It is directly proportional to length of the conductor. This we had discussed in previous class as well. And resistance of a conductor is inversely proportional to area of cross section of the conductor. If we increase the area of cross section, resistance decreases. Resistance of a conductor is inversely proportional to number density. It is inversely proportional to relaxation time. So it depends upon these factors. N is number density, right? Number density or number of particles? It's number density. Okay. So it depends upon relaxation time as well. So this we had discussed in the previous class. Okay. Now we have these two terms. So this means material of the conductor. We had discussed now that R, the value of resistance, it depends upon four factors. Length of the conductor, area of cross section, material, and temperature. And temperature of the conductor. On these four factors, on these four quantities, resistance depends on, and resistance can be changed by changing these quantities. If we change the material, if we change the temperature, if we change the length, if we change the area of cross section, then we can change resistance by changing these four quantities. So one quantity was temperature. है ना? एक quantity temperature थी out of these four. So we can relate temperature and relaxation time. How do we relate temperature and relaxation time? Tell me. How do we relate temperature and relaxation time? कैसे relate करोगे? See, if we increase the temperature, suppose I'm just, increasing the temperature, heat कर दो इसको, temperature increase कर दो. If we increase the temperature of the conductor, then electrons get energy in the form of heat. And this heat energy gets converted into kinetic energy of electrons. Electrons will move faster. More frequent collisions will take place. Collisions ज़्यादा हो जाएंगे, frequent हो जाएंगे. अब collisions जब frequent हो जाएंगे, तो जो relaxation time है, tau, relaxation time tau will decrease due to frequent collisions. Frequent collision से जो relaxation time है वो decrease हो जाए. Tau decrease हो रहा है. We are increasing the temperature. It decreases the relaxation time and increases the resistance. Now you can relate. So resistance of a conductor increases with rise in temperature. If we increase the temperature, then kinetic energy of the electrons will increase. They will start colliding more frequently, which decreases the relaxation time, because relaxation time is the time elapsed between two collisions. तो अगर collisions जल्दी जल्दी हो रहे हैं तो दो collisions के बीच वाला time कम हो जाएगा, है ना? अगर दो collisions के बीच वाला time कम हो रहा है तो tau decrease हो रहा है, tau decrease हो रहा है तो R increase हो रहा है. Any doubt in this? Please write this in your notebook. अच्छा, एक चीज और है. We know that R is equal to rho L by A, right? And R is from here we get R as M L upon A N E square tau. So from here we can get the expression for rho also. है ना? Compare these two, you'll get the expression for rho. What will you get? On comparing these two, you'll get for rho. LL common, AA common, it belongs to both. It's M upon A, not A, not A, not A, not A, not A. M upon N E square tau. Okay, so this is R and this is rho. And rho may, you will see that it depends upon number density and relaxation time. So rho depends upon material and temperature. On the other hand, R depends upon four factors: length, area, number density, and temperature or relaxation time. Okay. It is inversely proportional to tau, but it depends on temperature. This is what we say. Okay. Find the relaxation time for free electrons in copper if the density of mobile electrons is given. Density of mobile electrons is given. It is 8.4 into 10 raised to the power 28 per meter cube. So this is number density, right? So we'll write small n for this. Resistivity of copper at room temperature is 1.7 into 10 raised to the power minus 8 ohm meter. Mass of electron is given. It is 9.1 into 10 raised to the power minus 31 kgs. And charge on electron is 1.6 into 10 raised to the power minus 19 coulomb. So this is given to you. We have to find relaxation time. Now, this is what we have to find. कैसे करोगे? बताओ. मैं इसका solution direct कर दूंगी ना, सबको easy हो जाएगा. Rho is equal to M upon N E square tau. Please open the gate again. Okay, put the values here. M upon N E square tau, put the value of M. Mass of electron is given. It is 9.1. We know the mass of electron, right? अगर given नहीं भी है तब भी आपको पता होना चाहिए. Number density is given. It is 8.4 into 10 power 28 Charge on one electron is 1.6 in 10 power minus 19. So it is E square now. So we'll just square this and tau. The relaxation time we have to find out. The relaxation time we have to find out. And rho is given. Rho is the resistivity. Rho is the resistivity. It is given. It is 1.7 into 10 power minus 8. This is what we have. So you can find rho. Relaxation time. How will you find relaxation time? So tau is equal to 9.1 into 10 raised to the power minus 31 divided by 8.4 into 10 raised to the power 28 into 1.6 into 10 raised to the power minus 19 square. And this is 1.7 into 10 raised to the power minus 8. Now solve this for tau, relaxation time. What will you get? Have you got the answer? Have you got the answer? It's 2.49 10 power minus 14 second is the answer. Yes, microscopic form of Ohm's law, relation between J, sigma and E. J क्या होता है? What is J? Current density. And E is बताओ? J is current density, it's I upon A, right? And what is E? Electric field intensity. And what is sigma? Sigma is conductivity. What is sigma? As conductance we had, conductance we had discussed. Conductance is 1 upon resistance. In the same way, conductivity is 1 upon resistivity. So sigma is 1 upon rho. Now we are going to relate these three quantities. कैसे करें बताओ? I क्या होता है? How do we relate I and drift velocity? I is equal to A and E PD. Now what should I write? बताओ. I is equal to A and E PD. So I upon A is, we can move this I to the other side. What will we get? I upon A is equal to N E V D. And this I upon A is J. I upon A is J. And VD is E tau by M. Yes. So we can write this as N E square tau E by M. Any doubt in this? Okay, now give me the expression for rho. Resistance we had found out, na? Yes. What is resistivity? M upon N E square tau. So what should I write for conductivity? Conductivity is 1 upon resistivity. So what should I write? N E square tau by M. Yes. So now we have this I upon A. We can write J for I upon A. Yes. It is equal to this N E square tau by M is sigma and E. This is microscopic form of Ohm's law. J is equal to sigma E. Okay? This is current density. So current density is equal to conductivity multiplied by electric field intensity. Okay, now we have potential difference of 100 volt is applied to the ends of a copper wire 1 meter long. So we have a copper wire. Okay, we have a copper wire and length of the copper wire is 1 meter. Potential difference applied on this copper wire is 100 volts. Calculate the average drift velocity of electrons. What we have to find is drift velocity. BD find करना है हमने. ठीक है? Compare it with thermal velocity. Again, we have the similar question that we had discussed in the last class, right? Thermal velocity we have to find at 27 degrees Celsius. So temperature is given. Temperature is 27 degrees Celsius. So first we need to convert this into Kelvin. What will you get? It's 300 Kelvin. And thermal velocity we need to find out, because we have to compare, we can compare only when we'll find the thermal velocity, right? Thermal velocity we have to find, drift velocity we have to find. Now consider there is one conduction electron per atom. So we have one electron per atom. This is given to us. Density of copper is given. Density of copper is 9 into 10 raised to the power 3 kilogram per meter cube. Atomic mass of copper is given. It is 63.5 gram. Avogadro's number is given. It is, and not we can write, it is 6 into 10 raised to the power 23 per gram mole. And Boltzmann constant is given. It is 1.38 in 10 minus 23 joule per Kelvin. आपको उनकी values learn होनी चाहिए. नहीं भी दियो तो आपको पता होना चाहिए. Conductivity of copper is sigma. Sigma is given. It is 5.81 into 10 raised to the power 7 per ohm per meter. These quantities are given to you. What we have to find is Vd and Vt, thermal velocity and drift velocity. So what is the formula of thermal velocity? It's without under the root of, we had discussed in the previous class also. Without thermal velocity क्या होती है? हाँ बताओ. Thermal velocity क्या होता है? Under the root of 3 kT by, this is thermal velocity. And how do we find drift velocity? It's minus EE tau by m. क्या होती है? Drift velocity is minus EE tau by m, है ना? Drift velocity क्या होती है? Minus EE tau by m. Sorry. Or we know one more relation. It's minus E tau by m, or I is equal to A N E Vd. I is equal to A N E Vd. So we can write Vd from this expression also. It's I upon A N E. Yes. And one more thing. This I upon A is J. So J is equal to NEBD. And how J, sigma and E are related? J is equal to sigma E. How E, B and L are related? E is equal to V by L. We know the length of the wire and voltage, right? So E is equal to V by L. Sigma is given, V and L is given. अब देखो क्या क्या given है. अब now we know all, we have written all the formulas that we can use here, right? So what is given? Length is given, voltage is given. So from these two we can find electric field intensity. है ना? E is equal to V by L. What will you get? It's 100 volt per meter. एक काम हो गया, एक स्टेप आगे आ गए हम. ठीक है, एक स्टेप आगे आ गए ना. अब नेक्स्ट स्टेप में सिग्मा इज conductivity, it is given. Electric field intensity we have just found out. So we can write, beta देखना जरा, J is equal to sigma E. We can find current density. We can find current density, yes. Current density क्या आएगा? सिग्मा की वैल्यू पुट करो. सिग्मा इज कहाँ पे है? करंट डेंसिटी ये था ना, ये रहा 5.81. सिग्मा इज 5.81 into 10 raised to the power 7 per ohm per meter. इलेक्ट्रिक फील्ड डेंसिटी हमने फाइंड करा है अभी 10 power 2. तो ये आ गया 5.81 into 10 raised to the power 9. What is the unit of current density? करंट अपॉन एरिया है. यूनिट क्या होगी? एम्पियर पर मीटर स्क्वायर. ठीक है, सिग्मा आ गया. अब जे आ गया, सॉरी जे आ गया. अब क्या करेंगे हम? J is NEVD, so we can write VD as J upon NE. Now put the values. Value of J, value of N, and value of E. How will you find N? Do you know the value of N? The value of J we know. Value of E is known to everyone. It's just charge on one electron. We know the charge value of charge of one electron on one electron. अब जो find करना है वो है number density. Number density क्या होता है? How will you find number density? We have to find number of electrons per unit volume. कैसे find करोगे? Number of moles का एक relation था. Mole concept you have done. Mole concept says that it is given number of particles divided by Avogadro number, given mass divided by molecular mass. ठीक है? Now here we are taking one electron per atom. एक इलेक्ट्रॉन में एक एटम में एक ही इलेक्ट्रॉन है. वन इलेक्ट्रॉन पर एटम का मतलब क्या है कि एक एटम के अंदर वी हैव जस्ट वन इलेक्ट्रॉन इन वन एटम. ठीक है? अब बताओ कैसे करें. नंबर डेंसिटी कैसे फाइंड करोगे? Density is given. It is density of copper is this 9 in 10 power 3 kilogram per meter cube. We can find density in grams because when we use the mole concept, we take the mass in grams, right? It is 63.5 grams. So we need to convert this density into gram per meter cube. So in gram per meter cube, we can write, what should I write? 9 into 10 की power 6. should I rub this? Okay, if we have 6 into 10 raised to the power 23 atoms of carbon, atoms of copper, उसका मास कितना होगा? 63.5 grams. And here we are saying we have one conduction electron per atom. One conduction electron per atom. ठीक है? We have one conduction electron. एक एटम में एक ही इलेक्ट्रॉन है. और इतने सारे एटम्स का मास कितना है? तो एक इलेक्ट्रॉन, एक एटम, इतने सारे इलेक्ट्रॉन्स का मास हो गया ना ये. इतने सारे कॉपर एटम्स जो है उसका मास कितना है? 63.5. तो नंबर डेंसिटी अगर निकालना होगा तो कैसे निकालेंगे? फर्स्ट इन दोनों को डिवाइड करते हैं अगर, तो क्या मिलेगा आपको? अगर आपके पास वन कंडक्शन इलेक्ट्रॉन पर एटम है और इतने सारे एटम्स का मास ये है, तो एक एटम का मास कितना होगा? डिवाइड करेंगे 63.5 डिवाइडेड बाय 6 into 10 raised to the power 23 grams. ठीक है? We know the density. Density of copper is 9 into 10 raised to the power 3 gram per meter cube. किलोग्राम है ना? ठीक है? So in grams we can write it is 9 into 1000 multiply कर दोगे 10 raised to the power 6 gram per meter cube. You have density in gram per meter cube, and here this is the mass of one atom, है ना? ये डेंसिटी है, ये एक एटम, ये ग्राम में है, ये ग्राम पर मीटर क्यूब में. इन दोनों को अगर हम सेट कर दें, एडजस्ट करें ऐसे कि तो हमें पर मीटर क्यूब में डेंसिटी नहीं मिल जाएगी? क्या करो? कैसे करोगे? अब तो मैंने बहुत इजी कर दिया आपके लिए. इसको नीचे रखें या इसको ऊपर रखें? क्या करें? कैसे डिवाइड करोगे इन दोनों को कि आपको पर मीटर क्यूब मिल जाए? मतलब यहाँ पे ग्राम है और यहाँ पे ग्राम पर मीटर क्यूब है. इसको ऊपर रखते हैं, इसको नीचे रखते हैं, तो ग्राम से ग्राम कैंसिल नहीं हो जाएगा? तो आपके पास जो आंसर आएगा वो पर मीटर क्यूब में नहीं आएगा. नहीं आया समझ? पक्का? मुझे लग रहा है अभी थोड़ा कच्चा कच्चा हल्का हल्का ही आया है, ढंग से नहीं आया। देखो ये ग्राम पर मीटर क्यूब है, ऐसे लिखो इसको, ग्राम से ग्राम कैंसिल हो जाएगा, है ना? ठीक है। तो नंबर डेंसिटी कैसे फाइंड करोगे? नंबर डेंसिटी के लिए क्या करेंगे हम? इसको किससे डिवाइड करोगे? 9 into 10 raised to the power 6 in the numerator, and this 63.5 here, and 6 into 10 raised to the power 23 here, and you will get your answer in per meter cube. Okay, and answer that you are getting is 8.5 into 10 raised to the power 28 per meter cube. This is the number density that we are getting. ठीक है, क्लियर? नंबर डेंसिटी आ गया। शुड आई क्लियर दिस? अब आपने मुझे बताना, यू हैव रिटन एवरीथिंग ना, नाउ यू टेल मी द वैल्यू ऑफ जे दैट वी हैव गॉट। 5.81 10 to the power 9 एम्पियर पर मीटर स्क्वायर। और उसके बाद क्या फाइंड किया था? नंबर डेंसिटी की वैल्यू क्या आई है? 8.5 into 10 to the power 28 per meter cube। VD, we have to find VD, right? Drift velocity। Then drift velocity के लिए हमने क्या रिलेशन लिखा था? I is equal to a NEVD, I upon a is NEVD, so J is equal to NEVD, so we can write VD as J upon NE। J is 5.81 into 10 raised to the power 9 divided by value of N is 8.5 into 10 to the power 28, and value of E is 1.6 into 10 to the power minus 19। ठीक है? So substituting all these values, you'll get the drift velocity as 0.4. This is what you're getting, 43 meter per second. This is the drift velocity that we got. Now we have to find thermal velocity. Thermal velocity is, how do we find thermal velocity? Let's write Vt for thermal velocity. It's square root of Tkt by m. Put the values. K is Boltzmann constant. So 3 into 1.38 into 10 to the power minus 23। टेम्परेचर कितना गिवन था? 27 डिग्री सेल्सियस। केल्विन में कन्वर्ट किया था, क्या आया था? 300। ठीक है, और इन द डिनोमिनेटर वी विल राइट द मास। मास इज द मास ऑफ इलेक्ट्रॉन, it's 9.1 into 10 to the power minus 31 under the square root। Okay, so on solving this, you will get drift this thermal velocity as 1.17 into 10 raised to the power 5 meter per second। This is the thermal velocity। ये drift velocity है और ये thermal velocity। Now you compare these two। देखो drift velocity कितनी कम आई है ना, drift velocity हमेशा कम आती है ना, ये हमने ध्यान रखना है बेटा। और ये क्या है? thermal velocity। इसका ऑर्डर देखो, 10 की पावर 5 मीटर पर सेकंड, मतलब एक सेकंड में 10 की पावर 5 मीटर, इतना डिस्टेंस, बहुत बड़ा डिस्टेंस होता है 10 की पावर 5 मीटर। एक छोटा सा इलेक्ट्रॉन इतना डिस्टेंस कवर कर लेता है एक सेकंड में। थर्मल वेलोसिटी कितनी ज्यादा है। ठीक है, तो अब आपने कंपेयर करना है। क्वेश्चन में क्या था? कैलकुलेट द एवरेज ड्रिफ्ट वेलोसिटी, फिर था कंपेयर इट विथ थर्मल वेलोसिटी। कंपेयर इट विथ थर्मल वेलोसिटी, हाउ डू वी कंपेयर? फॉर कंपेयरिंग वी डिवाइड। ठीक है, डिवाइड देम। ड्रिफ्ट वेलोसिटी डिवाइडेड बाय thermal velocity, so put write 0.43 here, and the value of thermal velocity is 1.17 in 10 to the power 5। What answer you're getting? अच्छा, यूनिट क्या आएगी? आएगी मीटर पर सेकंड लिखो, क्या लिखो? आएगी यूनिट? कट जाएगी? नो यूनिट्स, बिकॉज हम सिंपल कंपेयर कर रहे हैं इसको, है ना, वेलोसिटी को वेलोसिटी से। नो यूनिट्स। ठीक है, yes, if I is the current for a certain V, then reversing the direction of current, keeping its magnitude fixed, does not produce a current of same magnitude as I in the opposite direction. इसमें क्या है कि सपोज जैसे ये आपका V प्रोपोर्शनल टू I ये ग्राफ है, ठीक है, तो इसमें ये स्केल हम चूज कर रहे हैं. So this is voltage and this is current. So this dashed line represents the linear Ohm's law. मतलब theoretically this is Ohm's law. जो dashed line है आपकी dotted line, it shows the Ohm's law. But practically line is a little curved. For higher values of potential difference and current, it is not linear. It is slightly curved from the straight line graph. Okay. The solid line is the voltage versus current for a good conductor. So this is the ideal condition. This dotted line represents the ideal condition for an ideal conductor. Ideal conductor जो है वो ideally follow करेगा ना Ohm's law. वहां पे V proportional to I proportional to V ले रहे हैं हम. But अगर आपका conductor, if you're practically, experimentally, for a good conductor, we get a curve for higher voltages. ठीक है? When we increase the voltage, after some time, the value of V, it is not linear with I. This is for conductors. And for a diode, we get this kind of thing. You can see when we change the voltage on the positive side, we are getting the value of current changes in a different way. But when we change the voltage towards the negative side, है ना, अगर वोल्टेज को नेगेटिव की साइड लेके जाते हो आप, तो करंट की वैल्यू में चेंज कैसे आ रहा है? लुक एट दिस. हियर यू कैन सी दैट करंट इज मतलब हल्का सा ही लीनियरली इंक्रीज हो रहा है एंड देन अब्रप्टली इंक्रीज हो रहा है. अपवर्ड साइड में इनिशियली करंट इज लीनियरली इंक्रीजिंग, देन इट इज इंक्रीजिंग अब्रप्टली. बट जब आप नेगेटिव साइड में जा रहे हो तो इनिशियली व्हेन यू इंक्रीज द वोल्टेज देयर इज वेरी स्लाइट चेंज इन करंट, बट आफ्टर सम टाइम वी गेट अ ब्रेकडाउन and current increases rapidly in the negative direction, the opposite direction. It shows the opposite direction. जैसे आपने बैटरी को उल्टा लगा दिया तो उसकी करंट की डायरेक्शन चेंज होगी. It's like that. So diode में we have forward biasing and reverse biasing. ठीक है, तो when we'll study forward biasing and reverse biasing, then you'll get to know. You'll understand this curve in a better way. After this, we have this graph. So this graph represents current versus voltage for a semiconductor. Gallium arsenide, you can see. So यहाँ पे you will see that this graph is again it is not following Ohm's law. These are non-ohmic conductors. So यहाँ पे you can see that for one value of for two values of voltage we have the same value of current. If we just join these 2 points, you can see for these 2 points, for these 2 points, right? So we are getting यहाँ पे अगर आप देखोगे ना तो जैसे इस पर्टिकुलर पॉइंट पे एंड इस पॉइंट पे वी आर गेटिंग द सेम अमाउंट ऑफ करंट. फॉर डिफरेंट वोल्टेजेस वी आर गेटिंग द सेम वैल्यू ऑफ करंट, है ना. सो फॉर टू डिफरेंट वोल्टेजेस वी हैव द सेम अमाउंट ऑफ करंट. अगेन हियर फॉर टू डिफरेंट वोल्टेजेस वी हैव द सेम अमाउंट ऑफ करंट, दिस करंट. अगेन फॉर टू डिफरेंट वोल्टेजेस दिस एंड दिस वी हैव द सेम अमाउंट ऑफ करंट. So this graph is not following Ohm's law. ठीक है, any doubt in this? Ohm's law is neither a basic law nor a derivable one. V is equal to IR is just an empirical relation. Microscopically, Ohm's law is expressed as V is equal to I into L by sigma A, where sigma is the electroconductivity of the material. This we have discussed. Okay, J is equal to NEVD and J is equal to sigma A. This we know. We have just found out. And potential difference is applied to the ends of the conductor. Free electrons get accelerated. ये भी पता है हमें. हम potential difference apply करते तो electrons accelerate हो जाते हैं. ठीक है. And when they move, they collide against the atoms or ions, and thus their motion is opposed. This opposition offered to the flow of charge through a conductor is called resistance. ये भी पता है हमें. ठीक है. The resistance of a conductor depends upon the nature of material, dimensions of the conductor, physical conditions like temperature. तो यहाँ से pressure, dimensions like length, cross section, etc. तो ये रिवाइज हो रहा है क्योंकि हमने किया वो पॉइंट्स वी आर जस्ट रिवाइजिंग. ओके, व्हाट आर द लिमिटेशंस ऑफ Ohm's law? नाउ यू कैन टेल मी द लिमिटेशंस. दैट इट इज ओनली वैलिड फॉर आइडियल कंडीशंस, फॉर गुड कंडक्टर्स, even for good conductors, for at higher voltages it is not linear, it is slightly curved, है ना. So, although Ohm's law has been found valid over a large class of materials, there do exist materials and devices used in electric circuits where the proportionality of V and I does not hold. कहाँ कहाँ hold नहीं करता? Semiconductors में hold नहीं करता, insulators में hold नहीं करता, right? The deviation broadly are one or more of the following types. V ceases to be proportional to I. The relation between V and I depends on the sign of V. अभी देखा था ना कि जिसमें नेगेटिव पॉजिटिव हो रहा था, we were getting two values, है ना? This like things like these we get. The relation between V and I is not unique. That is, there is more than one value of V for the same current. This we have got for one graph, है ना? आया था ना? Materials and devices not obeying Ohm's law are actually widely used in electrical circuits. We use semiconductors, we use integrated circuits, we use insulators, other kind of material also use electrolytes, conductors. These do not obey Ohm's law. Ohm's law is not a fundamental law like Newton's law, as it is not obeyed by all the substances. Newton's law of gravitation is obeyed everywhere. It is universal law. That's why the name is universal law. But Ohm's law is not universal law. Okay? It is an empirical formula just used to find the potential difference across the conductors. Ohm's law is valid only for linear conductors in which V upon I ratio is constant, such as metals.